Hey guys, look at this one called write an equation of a circle given by the endpoints of a diameter. This is a very interesting one because let me do a drawing first. We have the endpoints of a diameter. That means that let me make a drawing. That means that the circle, the circumference passes by minus 5, comma minus 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it passes through this point. I'm going to write the coordinates in here. And passes through this other point, 3, comma minus 6. 1, 2, 3. We already have 4 in here. 5, 6. Okay, this is the other point where the circle passes by. Let me use the magic from Zoom to help me drawing this one. Okay, more or less something like that. All right, so the circle passes through those points. Actually, it is not so accurate. That is supposed to be a diameter. Yeah, that is a diameter. That means that the midpoint of that diameter is the center of the circle, right? This is the center. And we want to know the coordinates of that center. To calculate the coordinates of that center, we are going to do this. This is a formula. Let me put this first. This is x1, this is y1, this is x2, this is y2. It doesn't matter if you choose this to be the first one and this to be the second one. The only thing that you have to have is the same sub-index in the same coordinate. You cannot put like x1 y2. That is going to be wrong. So just be careful with that. Now the coordinates. Remember, in here we want coordinates. The coordinates of this point is going to be the average of the x's. Like when you calculate the average of your grades in any course in the school, you calculate the average of both x's, of both part of the x's in the coordinates. So this is going to be minus 5. Be careful with signs. Plus 3 divided by 2, comma minus 4. Be careful with this one. Plus minus 6. And minus 5 plus 3, that is minus 2 divided by 2. Okay, minus 4 plus minus 6, that is minus 10 divided by 2. And this is minus 1 comma minus 5, right? This is the coordinates. These are the coordinates of the center of the circle. So, as you know, the coordinates of the center of a circle are the h and the k parts of the standard equation, right? Now, the other thing we have to calculate is the radius. And the radius is going to be the distance from the center to any of the 2 points. I'm going to pick this second point. This is still going to be x2 and y2, and this is going to be my new x1 and y1 to use them in the Pythagoras theorem. This is going to be the radius. Radius equals, using the Pythagoras theorem, remember it is x1 minus x2, the difference between the x parts of the coordinates, plus the difference between the y parts of the coordinates. Substitute, and we will have minus 1 minus 3 squared plus minus 5 minus 6. Be careful with this one. I'm going to write it like this. Oh, I'm missing one parenthesis. Yeah. So be careful with that one. This is going to be minus 4 squared plus minus 5 minus minus 6 is minus 5 plus 6. That is just 1, right? Okay, that is something to be careful, the signs in the formulas. Now 4 squared is 16 and 1 squared is 1. So this is the square root of 17. Okay, we're ready to write down the equation of our circumference or the circle. This is just going to be 70. The radius, well, not the radius, I mean the how it will look in the equation. The radius is the square root of 17. But if you square that, the square root of 17 squared will cancel both the square root and the square, so it is just 17 in the equation. And in here we have x minus minus 1 is plus 1. And then y minus minus 5 is plus 5. We ought to check this. Thank you.